Hey gamers, my name is Leszek. Today I will be talking about AI and how we are doing it in Lumencraft. So, as you can see here, we have four basic enemies. This is our first AI that we had in the game. This is a swarm enemy. It's basically designed to act like a swarm, but for some performance issue, it's not that big of a swarm. So, as you can see, the guy triggered and he's following me. So let's see how they behave. They are basically have a range of sight 100 pixel or 100 units in world space of the game. So as you can see, they will try to follow me, bite me whenever they can, like jump a little bit and try to avoid each other if they can. So they operate with super simple rules. So the one is just follow the player if you can see them. The second is like attack them when you are in range. They have an option to attack building as well. And there's some other like custom things. So the next one is pathfinding. So whenever a player is like hides of this line of sight, they will try to go to the last known position, and then if they still don't see him, then they will switch for a pathfinding algorithm. We'll see debugging information in a moment. And the last thing is they actually can follow the guy in front of them. So this creates some like interesting behaviors that are completely random, and nothing of this was like intended. So let's trigger spawners here, and we can see how it works on a larger scale. So as you can see, we have a swarm, and they are trying to like spread around, like they are walking over each other, they are bouncing off the walls, trying to avoid collisions, and yeah. So you can see how it works. So one last thing the AI can do is actually they can attack this terrain over here. If they get stuck on it and they decide they are too long, like not moving from a space, they can try to like bite the pieces of wall, and that's why you can see some debris are lying around. So that's basically it. Let's try and see how it actually works. So let me go to the editor. Actually, let's quit the editor. So this is our dude. So let's talk about how is he done. So he has a walking speed. So 64 is basically like 4 pixels faster than player, I think. So let's reduce his speed to something more manageable. He has the 2 attack animations. So this is a bite attack and long attack. I will show the animation in a second. Sight range, this is the distance when they will like notice a player. Normally it's a little bit higher, but for the presentation I reduced it. Animation travel speed is basically for matching the speed, the animation to the movement speed. Pathfinding resolution is for pathfinding, and when you like need to find a path wide enough that the monster can actually squeeze through the corridors. So that's the resolution thing for. Wall repulsion, this is for wall avoidance, and the collision distance. You can basically see some colliders and attack shapes inside, and slowdown radius for like them actually slowing down when they arrive to a position. That's rarely seen, but it's there. So yeah, they basically idle animation looks like something like this. Normally, if you see a monster doing this, there's some like 2 pixel animation. You cannot really see it because those guys are really tiny. So we have a bite, it's fast attack. We have a claw, that's a bit longer. We have a death animation, some idle, yeah, we can see that. Roar, this is not used by this monster. We have some larger version of this dude because like this is like, it's basically this animation would be used if you want to indicate for a player that the monster noticed him, but the swarm is basically super aggressive and they are super small, that we don't use that for this guy. And obviously walking. So as you can see, all the monsters are basically sprite sheets with frame-by-frame animation. So there's not much trickery there, but they are 3D models that were printed like this. So I did reduce the movement speed. Let's give it like something 12 or something. Let's try it again. Let's go to the editor. Let's load monster test. So this is our test map for now, and let's test it. So let me disable the infinite health, some special effects, grab the guns, and trigger the dudes. And let's turn off the debugging information. So the cyan color is a line of sight basically. So if they are reaching the player, so the monster actually sees the player. If they are like something like this, so this is the last place the monster seen the player and trying to go to the last position. Another one will be in yellow in just a second. So you can see, oh there we go. This is basically a pathfinding. So if the monster cannot see the player and he went to the last position he saw the player in, and he tries to pathfinding to the player. And there's some other things that you want to see. Let me just bundle the guys together and maybe try to pull them inside the terrain. It's actually hard to trigger. Basically they need to be forced moving into the wall, and this basically happens if other monsters tries to push them or some avoidance force them to do this. So you can see if the monster is trying to hit the wall, it will get some reflections from array, and that tells them try to avoid this wall by going to the reflection position. Whatever, but let's try to make them a swarm a little bit. Okay, so as you can see on the last dudes, they are connected with a blue dot and white line. This means that the guy in front is basically the leader of the guy in behind. So now they are connected entirely. So this guy see me, he follows to my position, and all the other guys are just following the guy in front. So this is a way to optimize and don't do much pathfinding and ray tracing. But additionally, unintended behavior was that they actually organize in a swarm-like manner, and that's pretty cool. So let's trigger the whole so we can see how it works in a bigger scale. Now the debugging information will be super messy, but you can see they are actually trying to follow the guys in front. They're creating this weird mesh of connections. They can separate, and it's just happening naturally. Let's disable the debug information. It's a little bit cleaner. And again, so the yellow guys are doing the pathfinding stuff. That's probably needs some optimization so that not every guy that cannot see the player does this. And you can see some wall reflections of the terrain as well. So these simple rules made the swarm pretty interesting and behaving attacking the player from multiple directions. Some of the guys are wandering off and going back, and it's created some character to the monsters, but it's super simple. Yeah, some are still stuck in the terrain and not sure which way to go. That's basically happens because that. Okay, so another one is the new swarm. So let's test it. So we have pretty much the same map. Let's disable some effects, and here we have another swarm. So as you can see, we have 500 monsters here, and their behavior is based on Craig Reynolds voids or flocking. I'll show you the link in a moment. So as you can see, those monsters are aggressive when you are close, and the others are wandering around. They're trying to spread around and cover the space. So it's a little bit less aggressive than the previous one, but this one is really solid to fill your tunnels with monsters. So they are quite making it quite difficult to go through them. And they have additional behavior. They can react to light. As you can see, they are running away. Okay, so let's see what's happening behind the scenes. So first, let me show you, this is based on the string behaviors for autonomous characters by Craig Reynolds. You can go through this paper. It pretty much explains every behavior that's there. I strongly recommend it. This is a solid one. And let's go back to the editor and let's enable not this one. Let's enable the debugging tool. As you can see, the monster have pretty much like lots of different parameters you can tweak. So the speed you already know, like maximum HP and so forth. But this is the weights of the behavior system that's happening below, and you might be able to tweak those in our editor at some point. But for now, they're only available inside the engine. Let's see what's going on when we go to the editor, and let's open it. Let's test, and again, darkness, smoke, infinite health, and maybe we can draw some stuff. So as you can see, the performance will go down because of all the debugging stuff. But you can see what's the position when they are trying to move to, which are focusing on the player, and like if I throw a flare, which of those guys are trying to avoid the fire. You can see they are creating like ant-like behavior. They can like spin in circles, like create a like tornado of monsters, and they like wander around, avoiding walls and doing their stuff. Okay, so let's go back to the editor once more time. Let me hide this again, and let's show off another map. Let's go to this one and let's test it. So it's pretty much the same map as before, but it's a little bit more showing off. So you've seen those guys. I'll try to push forth. There's a little bit more of the map here, and we've got just a little bit more of those monsters. So as you can see, this swarm can actually support like a lot of monsters. I believe there's like 5,000 units on the scene right now or something, or they are even generating new ones, not sure. Do they react to the light? It's a little bit cramped, they might not be able to, but as you can see they are trying to avoid it. Yeah. So let me just show you another project I have here. So like it's really no point for me to explain how those things work, because the Craig Reynolds article just does this much better. But this is like a super simple project that shows you what's going on. So basically the monsters have like a view angle, view range, separation range, and some parameters, like for example the alignment, cohesion, separation are the three basic ones. And those parameters basically tell you like the alignment, and tells that the monsters inside the circle are trying to follow the same direction, like the weight average. The cohesion tells them to try to move to the center of gravity of the monsters around, and separation says pretty much avoid guys around me. Like you can see, this one is displaying all the information that's there, and those simple rules create all the behaviors. The rest is like speed and whatever. Like you can make him slower or something. So that's basically it. It's not that complex, but it works really well, and you can see the behaviors are pretty much like quite interesting and quite dynamic, that they can blend together. It's like create the spinning circles. It looks like actual like some simple minded monsters doing something. Okay, so another one will be context behavior. So check back in a moment. Thank you. Okay, so the last one is context-based steering behavior. So what we have on this this test map is this little 5 dudes, and the music changed, so that tells me that this guy is in a state, it's called state follow target, so he's following the player that's actually in range, in his line of sight. And I'm overriding the target position he wants to go using a mouse cursor. So if I like place a cursor right on top of the player, it would work like, for example, like expected, I guess. So what I want to show you here, so each of those dudes has a set of vectors. Those vectors are called interest map. So it basically, for each direction that I created here, it depends on the navigation resolution. For this one is like 180 degrees and 7 rays. You can customize this. I will show you that later. So for each direction, it calculates how much that direction is the direction that the monster wants to go. So for example, if I have it on the player, so the best option is to go straight using this vector, or if I rotate it really fast, you can see the lengths of the vectors change. So that tells me that you want to like rotate left or right. So let them go to the wall, and you can see for interest map you have also like a danger map or a map for avoiding things. So you can see there are some vectors like little yellow lines that they display that okay, that direction is not really a valid solution, so that's why they are there, and then you know that you cannot choose one of those vectors to follow. So for example, if we want to go to the wall, they will try to follow the wall, and at some point they will just flip around because the weights recalculate and they tell them okay, turning the other way is the better solution. So you can like aim at the player and they will start attacking, that the state will change to attack the player, and they can avoid each other. And this is quite complex because you have like a set of states for those dudes, and you can modify what's what they are interested in. They want to follow a target or follow a building, target a building, or avoid walls or attack walls, and you can create lots of custom things. But for now, yeah, we have something like this. They try to avoid each other and they follow a cursor. So let's stop it and let's disable the override. Let me quit. So, not this one. So we got this dude. So we have the context controller. As I said, his navigation is like 180 degrees. I can make it like 360. So the navigation is a little bit more complex, but for the reason I'm using this because our monsters are not intended to like rotate really fast to go backwards, so there's no really reason to have a navigation that's calculated 360 degrees, and you can change the navigation map. So this little dude, actually, no, let's go for this one. So this is the big spider that's actually using the generic dude AI, and he has some custom like states. So you can see the generic dude has like a lot of things going on, but the actual spider that we'll show in a moment has actually two states that are unique for him, and this is a state for dying because there's a separate animation, and there are state for attacking because he has a constant attack state. So we have lots of states that can help you like choose the behavior. So we know the guy from the previous example, so the same goes here. He's a little bit bigger, and let me disable the thing I wanted to disable, and it was in global state, and overriding the position was set to mouse. Let's disable this and let's run it again, and let's see how the guy's behavior now. So this game the same stuff as before, but without overrides, so we can actually see what will happen. So those guys found a target and they actually want to flank the player a little bit, so they are choosing a position right next to the player, and when they are closing they are trying to like attack it from sides. So whenever the player goes like around, they try to like flank him, because if you want to shoot them then you have to like change your movement pattern, so they can surround you, and yeah, it happens something like this. So they obviously have a pathfinding. If the player gets like hides for like 5 seconds or something, then they will try to go to the last known position again, and they will try to find a path. They can obviously attack terrain and trying to avoid stuff. If you hide long enough, they will just go, okay, I just lost a player, and they will try to wander around and look for him, or just turn to idle. Because if you like go very far from monsters, you don't really want them to like take the processing power, so they turn off the logic, and they just try to wait or pretend that they are doing something. So let's actually see some actual monsters. Let me just disable those guys, let's get rid of them, and let's see something like the Pider is the basic one. It's pretty much the same logic as the generic we saw here, and let's see some others later. So as you can see, he's trying to flank me, but you can kite him if you really want to, but they're usually in pairs, or there are a couple of them. So if you get close, he starts to bite you. It looks like he's approaching a little bit too close. He should be biting from a distance, but yeah, as you can see how it works in practice. If I manage to like avoid him for long enough, he will lose his interest. Still following a path. I'm not sure if I can actually do this without cheating. Can I do this? Yeah. So he lost his interest and he just starts to wait and look around. So let's see some more interesting monsters. Let's go for this one. This is not work in progress. Shouldn't be in the game yet. Let's delete this one. You can see how this guy's working, and he basically has a constant attacks and a bit different navigation. So he has a more precise map, and he creates something like that. If he gets to the right distance, then he changes to the claw attack. If you get too close, he will like try to pounce you, I guess. Yeah, I'm not sure. There's actually work in progress, whatever. And we got something more like this one, this one, this one. This one is like varieties of the same dude, but each has different behavior. And let's drop some like that big dude at the end, maybe a little bit here. So we're still adding variety. There will be more monsters coming to the game. If I actually manage to disable the bugging for a moment, and as you can see, this guy exploded, that guy exploded in a pool of acid. This one is charging like crazy. Yeah, this one is spitting acid, and yeah, all crazy stuff can happen. And you just change a little bit of state logic and weights, and yeah, the monsters will do some crazy stuff. It's quite interesting to use this method, but it's really hard sometimes to avoid like little glitches, like stacking on the walls. It's like, yeah, that's normal, and fixing that. So yeah, so that's pretty much it. Let me show you the paper that is based on. Give a credit where credit is due. So this is basically the paper you want to check if you want to know what's going on behind the scenes. It's content steering behavior driven steering for macro scale, whatever, by Andrew Frey. Yeah, and it explains in detail what we are doing here. So as you can see, the desire map, the interest map, the avoid map, basically that. So thanks for your attention, and we invite you to play playtest that is still going on, and soon we'll hit early access. Bye.